Hello everyone, this is Eric Colvin, and I wanted to make a video to share with you guys something that I'm really excited about in Fusion 360, as well as Tormach's Pathpilot controller for their milling machines. I use a Tormach PCNC 770, and of course I'm using Fusion 360 as my design and CAM software. Additionally, I use the Pathpilot Setup, which is important for this tutorial. These are master jaws and soft jaws that repeat apparently to within 3/10. So those are the master jaws. You would replace your vice jaws, your hard jaws with these, your master jaws, and then these are the soft jaws that interlock with them, and then they are millable. These are the aluminum ones. They also make steel ones. I am also using the Hallmark ITTP touch probe. It's a really great piece of kit made by Cliff. I think it was well worth the investment. And in conjunction with that, I'm using the wireless kit from David Lumes. This thing is awesome. So it gets rid of the cable, as you see. And what's also cool is you see you've got two auxiliary ports, so you can leave your probe plugged in. This would, the back of this is where the 5-pin DIN cable would plug into the accessory port on the Tormach. And then in aux 1, I've got my ETS, my electronic tool setter, which lives on my table, plugged in to this. So I can have both the probe and the ETS plugged in, and Tormach knows which one is which. You don't have to switch it back and forth in settings. Very nice. This is with the Tormach passive probe, but he sells one designed to be used with Cliff's ITTP probe. That's the kit that I'm using when I'm talking about these probing routines. So why am I so excited? Well, first of all, you know that Fusion has had the probing capability for a little while now. And I'm talking about the WCS probe. If you want to use the geometry probing functions or the inspect service, you'll see you get a little notice that you have to buy these extensions in order to use those features. I'm not needing to use those features. I'm interested in the probe WCS functions, which allows you to set, say, let's do a Z probe. Let's choose that as our surface. Now this is it assumes that the surface is solid. In my case, it isn't. If I needed to probe this surface specifically, I would say use selection point, and you would see it would move it over to where I clicked it. If I want to do it somewhere else, you see now it's over there. So that's very useful. As well, it can probe, an inside bore or a boss around the outside. Like that. We'll get in a little bit more detail about the actual setup of the probing, maybe in another video, because this really is about the work coordinate system, and specifically the fact that now Tormach used to only offer 9 work coordinate system offsets. They were G54 through G59, and then G59.1, G59.2, G59.3. Now we've got offsets beyond 9, up to 500, you can see, which is amazing. To call them, we'll use G54.1 with a p-value afterwards, P10 through P500. 500. So we went from 9 offsets to 500 offsets. And why does that excite me? Well, I use my milling machine to make one product, and it's a microphone. It's a high-end microphone that has roughly 15 machined parts of various geometries and sizes. I'll give you a little shot here of what the final product looks like. This is the microphone that I make. It is brass, aluminum, and PTFE. What you're looking at on the outside is nickel-plated brass. I make these here in Los Angeles. And the part that we're machining today is the head basket, the ring of the head basket. You can see it down here. This is before it's been plated. So back to Fusion. I have 15 parts. All of them, there's a lot of lathe work. I do use my 770 to mill turn or spindle turn. The parts are small in length, so I'm able to get away with it. But all of them receive multiple milling ops, at least 2 for each part, sometimes more, sometimes only 1, but let's just say on average there's 2. So with 15 parts, 2 ops each, or 2 setups each, let's just say, and I'm doing 2 parts at a time. Typically, I do 2 parts at a time. That would be 15 times 2 for 2 setups. That would be 30 offsets there times 2. So that's 60 offsets. With 500 offsets available, I have the ability to dedicate a WCS for each and every setup of each and every part. This is facilitated by the fact that Pathpilot, your Tormach, will remember the offset even when you shut the machine down. And granted, you rehome your machine, etc. It's not that you can probe it once and never probe it again. But the fact that it remembers the offset to within the accuracy of your limit switches, so you're always going to be a few thou off when you power up, but it's well within the range we need to make this work. So we're talking about making 2 parts. Let's switch to our probing routine setup. You may have noticed that with one click, it brought up my fixtures and it brought up the second workpiece, which is amazing. That's a new feature in Fusion that apparently just came out. Synchronized active setup down here in the bottom of the menu. I have both of these checked, and it remembers what features, what things were. So I've got all of these selected as my fixture. I've got these 2 bodies, my stock, everything is remembered. So for instance, if I go to the second probing op, this would be the other side. I'm going to click that and activate that. Now it's flipped it over. You see that that's the underside of the part. So back to op 1. Watch here. Let's do it again. Whee! I think that's awesome because it's, sitting there checking and unchecking things, and you might have your fixtures like deeply buried into your tree over here on this side. Okay. So just a neat little feature here. Synchronized active setup. So I have decided to keep the first 100 positions, my work coordinate system positions, open. 2 of them are dedicated. One's my ETS on the table, and the other one is the rear corner of my fixed jaw. I think that's G59.2. And the ETS is G59.3, as those were the extremes originally of the 9 that we had. But now we have 500. And you'll see I've titled this setup Head Basket Ring P101 and P102. And by that, this is P101 and this will be P102. If we open it up, you'll see that just like when you want to do multiple work coordinate systems with an actual milling op, you can do it with the probing op by selecting the checkbox for multiple WCS offsets. I've got 2 instances, 1, 2. Increment of 1, and we're starting with 101. What that's going to do is it's going to probe this first workpiece, and it's going to probe the second workpiece. The reason that I'm so excited about this is that typically you have to rough probe. I would have to, on my mill, bring the probe. In fact, let's call up the stock that it's actually going to probe. You notice that, so this is the stock that I use, modeled, that will be probed. I always have my stock a different color. I choose, on the design tab, I choose A for appearance, and I give it a color. I choose yellow. That way I always know that this is stock. This is not an actual workpiece. We pull up our probe Z, and we'll see that it's going to use the rear soft jaw, the top of it, for the for its surface. Notice it's off to the side. I did that for a reason. Because I chose to have the probing routine use two different work coordinate systems, one after the other. Remember, if we go back here and deselect use selection point, it's going to put the selection point in the center of the face you selected. Well, if I left that, when it came time to do the second one, as it moves over, because you see our WCS is the center of this bore in plane with the, I'll just go front, in plane with the top of the jaw. When we moved over, it's going to move everything over. It's going to move this position over to here, and it's going to move this way out here in space, and the probe will error out because it won't contact anything. It is nice that if it doesn't contact something when it expects to within the over travel of 400 thou, which is a lot, it'll say, wait a minute, there's something wrong. So you don't have your probe going crashing into the table. So anyway, I chose this point slightly over here so that when it moves to the second probing Z, it'll probe over in that corner. Same with the bore. We're probing this bore. See that? Now, some of you might ask, why is it so low? Well, technically, this is a second op for this part. It had a milling op first. The outside profile was turned to size, and we drilled and took a light cut with a boring tool on the inside. And the only reason I have done that is it gives me something to probe. Yes, I could probe the outside, but I wouldn't be able to get in between these two with the diameter of my probe tip. So that would have posed a problem. And I'm using the 4-inch Carve Smart jaws because I am on a 770. The 4-inch vise fits nicely into the work envelope. Okay, so again, it's going to probe P101 as this part, and then P102. Now, yes, on the mill, the first time and the first time only that I run this probing routine, I'm going to have to rough probe P101. So in my MDI, I would type G54.1, P101. I'd guide the probe to the center of the part, and I'd zero my X and zero my Y, just roughly. At the same time, I could even probe this surface for Z. And then I would do the same for P102, G54.1, P102, rough probe, okay, my X and Y, and then my Z. But once I've done that once, those are going to be stored in Pathpilot indefinitely. And what's great is after I do this probing routine the first time, it's going to be even more accurate because now it's going to update itself. This probing routine will update P101 to dead center of this bore and right on this plane for Z, and it's going to do the same thing for P102. And then when it comes to the milling, let's hide the things we don't need to see right now. When it comes to the milling, it's the same thing. Notice that my origin is the same place as my probing routine. Let's put this back on here. No, this one. Go to the front. You can see that it's the exact same. It's on the same plane as the top of the soft jaw, and it's in the center of the bore of this part. And then I have all my milling ops that I'm going to run on this part. And then, like the probing routine, I have set it up to use multiple work coordinate offsets. I have two instances, 1 and 2, and I'm going to increment in 1, and I'm starting with 101. It's the same that the probe started with. So it's going to do 101 and then 102. And I have it set to order by tool, which means that it's going to do every operation it can while that tool is in the spindle, then it's going to move over to the other part, do the ops it can with that tool on this part, and then it'll change tools. Much more efficient than going through all of your operations and all of your tool changes on one WCS and then having to do it to the other. Sort of, I wouldn't say it defeats the purpose, but it's the better way to use it. So, why do I love this? Well, that means that for every part, look, I've got all of these parts here. that I make, and they all need to be probed for accuracy, and they all have multiple setups. And the fact that I can just load my probe into the spindle when it tells me to, and I can just hit cycle start, I don't have to rough probe anything except for the very first time. And so every time I go through these parts, it takes, I'm not saying that there's a hassle in probing. I mean, after all, you're probing for a couple of reasons. You're probing for accuracy. There's number one reason. But you're using the automated routines in Fusion because they're automated. Just the same reason why you're using a CNC mill in the first place. So why not take it all the way? And now with the wireless setup that David Lumes has developed, incidentally, in order to use the additional work offsets and in order to use the probing routines in Fusion 360, you're going to have a modified post processor that David Lumes will provide for free. And I will give a link to where you can find that so that you can update your post processor. So you can see with all these parts to make and all these different setups, wouldn't it be advantageous if every setup for every unique part had its own WCS that was not shared by any other part that you could rely on for the probe to go right there? That's why I'm excited about having 500 work coordinate system offsets in Pathpilot. So let's check it out. Let's go over to the mill and let's put it to the test. All right, so here we are at the mill. We're looking at the Pathpilot controller screen. Just to show you guys, if we go to offsets and then we go to work, we're going to see what I was talking about. We've got G54 through G59, 59.1, 59.2, 59.3. Again, that's for my tool setter, which lives on the table, and the top rear left fixed vice jaw corner. One thing to note, I'm going to go handheld here for a second, forgive me. So here's the setup. This vice stays in this position. It doesn't move. Every few months I take it up and, clean the bottom, deal with any potential rust, which usually there's never any in a climate controlled closet actually. The ETS, of course, and some other fixtures that live on the table. This is the CarveSmart system. Got the rear jaw. Okay. So, look at this. Now we go. Look at that. G54.1, P10 through P500. That's 500 work offsets. Notice that all of these are 0 because they haven't been offset yet. Notice these have numbers because they've been used. They have been offset. We're going to focus on P101 and P100. What's great is you can give it a name, since now it's going to be dedicated to this head basket ring op 1A and op 1B. The A would be the left side and the B would be the right side. All right, let's get to probing. The whole point of this is to be able to just put the probe in the spindle, call up your program, and hit cycle start. So we're going to come down and we're going to do our Z in G54.1 P101. We're going to pick up the bore. And it knows where to go because I've already run this routine several times. So in a sense, it's just updating itself, but specific to the exact part that is in the vise. And it shouldn't be that far off from the previous time the parts were in the vise, but these are technically not the same parts. That's P102 now. We'll get the bore for P102. And it's going to do the the X again. This is the Fusion 360 probing routine. It does X, then Y, then X again. And that's it. We are in. We're probed. Okay, so I wanted to show you what I was talking about when I said that the first time you run a new probing routine for a new work coordinate system that doesn't have any offsets in it yet, you have to guide the probe to where you want it to probe. You have to rough probe it. So let's find this hole. Let's get close. And we'll jog around. And once, so I'm saying that that is the center of that hole. Roughly. I don't have to be precise. I could technically probe it if I wanted to, which wouldn't be a bad idea considering I'm only going to have to do it once. But you can just rough probe it, 0 your X, 0 your Y, come back up, do the same thing for the other hole. Now I'm going to type in my MDI now, G54.1 P102, because that's the new location, and I'm going to find the rough center of that bore and 0 my X and 0 my Y. I'm also going to come over and do the Z, and for the Z you can literally just touch your Z off. Go to your probe tab, XYZ probe, and probe Z, set work origin. Okay, and so now I've pre-programmed or rough programmed my P102 and P101 work coordinate systems, and as soon as the probe runs, I'm never going to have to do that again, because it just it updated itself, and in fact it made it more accurate. So right now we're in G54.1 P102. So if I wanted to change to P101, I'm going to type G54.1 P101, and now you'll notice now we've updated. So when I'm doing my rough probing, I'm going to type in the MDI line, rough probe, set my X0, Y0 once I find the center roughly, visually with my eyes. Technically, I could probe it, actually probe it, which wouldn't hurt, certainly, may as well. And I only have to do that once. Every other time, as long as I leave this 101 and 102 and use it only for this part and this op, these offsets are going to stay the same. They will micro update by tenths, maybe a thousandth. Here you have it. Op 1 complete. Probing, Fusion 360, Pathpilot, multiple work offsets, one work offset for each unique part and setup. Thanks for watching.